Hey, I'm back with the first video in our series called Problems You Should Know How to Do. Today I'm going to focus on divisors. Prerequisites, it's not really much to this. Just, I think, if you don't know how to solve that question right there, you don't know what prime factorization is, I encourage you to go learn about that real quick and then hop back in here because that's going to be really important. Okay, gonna hop into our first problem. How many positive divisors does 360 have? Well, being able to determine the number of divisors a given number has is really important. In mathematics, math team competitions, you're gonna want to be able to do that without wasting your time on it. And so please do not go and list out all the divisors of 360 because that's a waste of your time. Don't do that. Because first, as I just said, it's a waste of your time, and you're going to have to do this with larger numbers, and it's not a great strategy. So, if you want, take a moment, pause the video, and think about the question, but do not list out all the divisors of 360. So, as I kind of hinted before, I guess more than hinted, but as I hinted, prime factorization is going to be really important. We're going to really want to think about all the numbers in this video in terms of their prime factorization. So, and first, 360 is not a huge number, but we're going to try to think about this kind of problem with a smaller number first, so 24. And so 24 in its prime factorization is 2 to the third times 3 to the first. And it's got these 8 factors, right? And this is really, it's very quick to list out the factors of 24. It didn't really waste our time. But the reason I listed them out is not just to show that there's 8, but what we're going to want to do is think about the factors here in terms of their prime factorizations, which is this and this. And what's interesting here, and what should be noted, is that all the factors of 24, all the divisors, are 2 to the 0th, the first, the second, or the third, times 2 to the, not 2, 3 to the 0th, or the first. And that's interesting. That should be noted because from that we kind of say that all the divisors of 24 are 2 to the x times 3 to the y, where x is an integer from 0 to 3 and y is an integer from 0 to 1, which you can kind of see pretty easily from the list we made to the bottom left. And so, why is that even important? What's the trick? Where am I going with this? Yeah, that is probably something you want to know. Well, the fact that we can take this and make that from that, right? Determine that 24, all the divisors are 2 to the x times 3y with these certain choices. Now, that's important because if we want to choose a divisor of 24, there's going to be, if we think about it in terms of its prime factorization, the factor, there's going to be 4 choices for x and 2 choices for y, right? As we saw, x can be 0, 1, 2, or 3, and y can be 0 or 1. So there's going to be 4 times 2 choices in total, and thus there are 8 choices, which essentially tells us there's 8 divisors of 24. Okay, that's interesting. So if kind of like if I wanted to sum this up in a quick little trick, right? If we take the exponents of the number, in this case 24, and add 1 to each of those exponents and multiply it all together, that's the number of divisors here. It's 8. And the reason it's plus 1, you kind of want to be able to understand that, why it's 3 plus 1 and 1 plus 1, is to include the possibility that you can take something to the 0th, right? 2 to the 0th and 3 to the 0th were options. Because if you did just one choice, right, you're saying, oh, it has to be 3 at first. Well, that's wrong. So the plus 1 is to include those possibilities. So hey, let's try this back with our original problem. How many positive divisors does 360 have? Okay, well, let's break it into its prime factorization, right? And now we take each of those exponents add 1 to each of that, and multiply it all out. And that gives us 24. Okay, so 360 has 24 divisors. And this is really applicable to any number we get. Put it with how many positive divisors does 5,292 have? Okay, pretty much just as simple. Break it down to its prime factorization. This is really quick to do with the calculator. Doesn't take that long to do by hand either. And then take all those exponents, add 1 to each of them, multiply it out. 5,292 has 36 divisors. Okay, that's kind of dandy. Okay, and so you might want to try this if you want to just practice this technique a little bit more. Try it with how many positive divisors does 34 factorial have. That might take a little bit of time, but shouldn't take that long at all. And if you can do that, I'd say you pretty much have this technique down. Okay, so let's branch out a little. So you probably noticed how we kept saying positive. Why does it matter that it's positive, right? Well, what if we change the question and said how many integer divisors does 5,292 have? You'd be like, yo, 36. No, they tricked you, bro. Because you can divide 5,292 by 2. You can divide by -2, huh? Yeah, and you still get a whole number, and technically not a whole number, but an integer, right? If you can divide it by 21, you can divide by -21. For every divisor of 5,292, every positive divisor, that is, you have a -1. So if we take the answer from before, multiply it for 2, so that we have both the positive and the negative divisors as 72 integer divisors. Okay, that's kind of important thing to keep in mind for math contests and math in general. So let's try another variation. How many, now we're just thinking about positive again, right? How many positive even divisors does 5,292 have? Okay, I'm going to let you think about this one on your own. It might take a bit of thought if you haven't done this much before, and that's completely okay. But I think if you understood the previous ones, you should be able to get to this one most likely. Otherwise, maybe we'll visit it again in a future video. Otherwise, on to the next problem. And this is going to be our last problem for today. Don't be too sad, because, hey, we're probably going to have another Math Team Problems You Should Know How to Do video on divisors. There's at least one more coming. Probably one more, because there's like probably about 3 more important types of problems that you really should know how to do. So anyway, to this problem, what's the smallest number with 10 divisors? Okay. Don't brute force this. Don't just jump into casework right away. That could take a while. So let's think about this. This it seems like a completely different problem than before. Like it has divisors in it, but it's not. It's different, right? It's kind of backwards. It's a similar thinking from the other ones, but if you got to kind of apply it backwards here. And this is a good spot to pause here, pause and ponder, because I'm not gonna go through as long as an explanation. I'm gonna kind of just jump right into it, give the answer pretty quickly. So if you want to think about it on your own, pause it. Otherwise, well, here's a hint I'll give you. This, you can think of 10 as 5 times 2, or as just as 10, right? And you can think of each of those as the number plus 1 kind of like format that you should recognize from earlier in the video. Okay. So if you're still lost, okay, here we'll kind of explain why that's helpful. If you have it's because 10 can be represented as that, right? A number with 10 divisors will look like either a number, right? A prime number to the 4th times another distinct prime number to the 1st, or just a single prime number to the 9th. Okay, right? And think about why that's so, right? Because if you take 9, add 1, that's 10. Oh, using the trick from here, you can a number to the 4 times a number to the 1st. You can use the trick we just did earlier to show that number has 10 divisors. So going backwards, we know a number with 10 divisors will be in one of these two forms. And so if we minimize a and b, right, because we want the smallest number with 10 divisors, okay, we make a and 2 and b 3 because those are the smallest prime numbers, right? We're going to get 48 and 512. And obviously 48 is smaller than 512, so that's our answer. Okay, that wasn't too bad, right? If you want, try this. I really encourage you to try this with other numbers. Like, try this with 8. What's the smallest number with 8 divisors? That's a little more interesting because 8 can be represented as 2 times 2 times 2, or as 4 times 2, or as just as 8. So you get 3 more possibilities. You kind of have to choose and compare, and then find what the smallest number it is. So play around with that if you want. And I'm going to go for now. This is the end of this video, but we'll be back with more. Till then, peace out, math people.